A planet that receives a signal from deep space surpasses all expectations and a competition to another star. What if we had it all? The universe we thought we knew is close to breaking. The James Webb Space Telescope JWST, widely regarded as the most advanced telescope, has discovered shocking secrets that could rewrite life's rules. But is Proxima B truly a new Earth or an extremely lethal trap in the vastness of space? Recently, the eye in the sky has turned its gaze toward one of the most intriguing exoplanets that have been found. Proxima B, this far-off world in the red dwarf star Proxima Centauri, has captivated enthusiasts and scientists since its discovery. But currently, with the extraordinary capabilities of the JWST, we are finally getting a closer look at this enigmatic planet, and the revelations are nothing. Proxima B was first discovered in 2013, but not until the James Webb Space Telescope arrived in the picture could we really explore what lies within this faraway world. The telescope's capacity to record infrared images has allowed astronomers to peer into the atmosphere of Proxima B, revealing information that was previously kept from view. The discovery they made has sparked both apprehension and excitement. You see Proxima B circling its star at a very close distance of only 7.3 million kilometers, which is less than 5% of the distance of Earth's proximity to the Sun, indicates that the planet completes a full orbit in only 11 to Earth days. But what's even more fascinating is the fact that Proxima Centauri, the star it orbits, is a red dwarf. In contrast to the Sun, red dwarfs are relatively stable stars known for their volatile nature, often producing massive solar flares that can drastically affect the planets orbiting them. Now, here's where things get even more fascinating. The JWST provided the most precise image of Proxima B to date, and it has shown some shocking features. First, the planet is 30% larger than Earth, indicating that it possesses a stronger gravitational pull. However, what is truly shocking is the possibility that Proxima B and its star are tightly bound. This indicates that only one side of the globe is in perpetual daylight, while the other is enveloped in perpetual darkness. A world where the sun never sets on one side and the other is sucked into a never-ending night. This tidal locking makes things difficult for any potential life forms. The side facing the star would be scorched by constant radiation. On the other hand, the dark side would be a frozen desert. This brings up a crucial question: could such conditions ever support life? In these extreme circumstances, the possibility appears slim, but nature sometimes surprises us. The difficulties do not end there. Proxima Centauri, in and of itself, is a significant threat to the habitability of Proxima B. As discovered by the JWST, the star is much more energetic than previously thought. Its powerful magnetic fields slam Proxima B with intense solar flares that hit the planet with a lot of energy radiation. In fact, a flare observed in April 2021 was 100 times more powerful than any flare ever seen from our Sun. An enormous surge of energy could strip away the atmosphere of the planet, leaving it exposed to the harshness of space. According to some researchers, Proxima B's proximity to its star and the frequent solar flares make it unlikely to sustain life as it currently exists. Others, however, suggest that life might discover a way to adapt to these extreme conditions. Could Proxima B contain organisms that have adapted to live in such an unstable environment, or is the planet doomed to remain a barren rock devoid of life? As we continue to explore Proxima B with the James Webb Telescope, more secrets are sure to be uncovered. But one thing is evident: this tiny planet, 4.24 light-years away, is far more complex and enigmatic than we ever imagined. Is it possible that Proxima B possesses the key to comprehending the universe's limits for life? And if so, what does that mean for our search for extraterrestrial life? Proxima B's stunning secrets revealed one of the most shocking findings: the planet's atmosphere, or rather, the potential lack thereof. The intense radiation from Proxima Centauri, combined with the planet's close orbit, means that Proxima B receives an incessant stream of solar wind and high-energy particles. This relentless assault may, over time, have eliminated the planet's atmosphere, rendering it barren and exposed to the icy void of space. However, here's where things get interesting. Some scientists believe that Proxima B might still retain a thin atmosphere, possibly composed of heavier gases like carbon dioxide or nitrogen, which could provide some level of protection from the star's radiation. The James Webb Telescope has given us the clearest glimpse yet of Proxima B's features and surface. The planet's surface appears to be rocky, similar to Earth, but with significant differences. For instance, the side facing the planet's star. Proxima Centauri has probably been scorched by heat, made a barren, desert-like landscape. In the meantime, the sinister side of the planet might be a barren, frozen wasteland, with temperatures falling far below colder than anything previously experienced on Earth. But the most intriguing possibility lies in the narrow strip of land in the middle of these two extremes, called the Twilight Zone. This is the place where day ends and night meetings might be more temperate, conditions where water that is liquid could exist. The fact that liquid water exists naturally, one of the most important components for life as we know it, could mean the Twilight Zone harbors a hidden oasis where life has managed to take root despite the harsh conditions on the rest of the planet. This revealed yet another shocking fact when scientists examined the possibility of the presence of water on Proxima B. The probable location it would be in the form of dark side ice or small, possibly temporary, bodies of liquid water in the Twilight Zone. But the discovery shocked a lot of people. The potential for oceans below the surface, like Enceladus or Europa in our own solar system. These oceans might be heated by the planet's core or by tidal forces caused by Proxima B's close orbit to its star. Assuming such oceans exist, they would be a great place to look for life beneath the planet's icy surface. But let's not forget the possible obstacles. The magnetic field of Proxima Centauri is an additional factor that increases the planet's complex environment. According to recent studies, the interaction between the star's magnetic field with the planet's core, generating its own magnetic field, might protect the planet's atmosphere from being completely depleted by solar wind, much like Earth's magnetic field shields us from the sun's radiation. But the circumstance on Proxima B is far from straightforward. Strong flares from the star could overwhelm the planet's magnetic defenses, resulting in sudden and dramatic shifts in the planet's climate and surface conditions. These discoveries raise more questions than answers. If Proxima B does have a magnetic field, how strong is it, and how does it influence the planet's atmosphere and potential for life? Could life on Proxima B have evolved to survive the planet's harsh and fluctuating conditions? If life does exist, what form would it take? Would it be something completely distinct from anything we've seen on Earth, or could it share similarities with extremophiles that flourish in the harsh environments of Earth? A hostile environment in which life faces significant obstacles, but the concept of a habitable planet circling Proxima Centauri is captivating. The reality is the James Webb Space Telescope has provided unparalleled insight into the challenges any potential life on Proxima B faces, and the picture is anything but rosy. One of the greatest difficulties is the world's exposure to extremely high radiation from Proxima Centauri. In contrast to our Sun, Proxima Centauri, a red dwarf star with significantly lesser mass and a more disorganized surface, constantly bombards Proxima B with intense solar radiation, including powerful flares 100 times stronger than the Sun's radiation. These flares produce a deadly cocktail of X-ray and ultraviolet light that would be lethal to any life forms similar to those on Earth. The effects of this radiation are not just theoretical. In April 2021, a particularly massive flare from Proxima Centauri was found, powerful enough to possibly strip away any potential atmosphere on Proxima B. This event serves as a stark reminder of the dangers posed by stars that are red dwarfs and casts doubt on the likelihood that Proxima B will be a haven for life. Moreover, the constant exposure to such radiation would make the surface of Proxima B an incredibly hostile setting. Any water on the surface would quickly become vaporized, and the rocky terrain of the planet would be scorched by the incessant heat. The gloomy side of the planet, while not exposed to direct radiation, would be equally inhospitable due to freezing temperatures. This extreme dichotomy between the sweltering day side and the frozen night side leaves little room for a stable, life-sustaining environment. The race to reach Proxima Centauri begins. While the signal from Proxima Centauri remains a mystery, reaching the star system has moved from the realm of fantasy to a genuine scientific endeavor. The Breakthrough Starshot Initiative, spearheaded by a team of visionary scientists and backed by prominent figures like Yuri Milner and Stephen Hawking, aims to send tiny, laser-propelled vehicles to the Alpha Centauri system of stars comprising Proxima Centauri within our lifetimes. The concept behind Breakthrough Starshot is as ambitious as it is revolutionary. The plan involves launching countless small spacecraft, each about the size of a postage stamp. These starships would be launched into space, equipped with cameras, communication equipment, and sensors to gather data as they proceed on their way to the closest star system. But what makes this mission truly groundbreaking is the propulsion system. Highly effective ground-based lasers would speed up these little spacecraft to a staggering 20% of light speed. This incredible speed means the starships might reach Proxima Centauri in just over 20 years, a blink of a cosmic eye. Once there, they would send data back to Earth, giving us our first close-up look at Proxima B and the other planets in the Alpha Centauri system. This mission's technology is just in its beginning stages, but the progress made so far has been nothing short of remarkable.